First, the robot gets in range and uses TensorFlow object detection with our Logitech web camera to determine the number of rings in the stack. It then launches 3 rings into the high goal, with the flywheel being operated on velocity using encoder ticks per second, so that it's always spinning at the same speed and the rings are launched at a consistent height. The robot drops off the first wobble goal and then backs up until the rear distance sensor is 18 inches from the wall and moves right until the right distance sensor is 7 inches from the wobble goal. It drops off the second wobble goal and parks. The first part of the program is identical for any number of rings until after the robot shoots. To line itself up, it uses the IMU sensor and the right side distance sensor to be straight and at a certain distance from the wall. The IMU sensor is used at many points in our program, whenever the robot is seen straightening itself out. This year is the first year our team has used on-bot Java as opposed to blocks programming. We found it much easier to use and have utilized many more functions and methods this year than in past seasons. We also use encoders now to have the robot go more accurate distances. For driver aids, driver B can have the robot rotate back to 0, driver A can adjust the velocity that the flywheel will spin to, and there's a gatekeeper servo safety guard so that the robot will only launch the rings when the flywheel is spinning in a narrow range of velocity, centered at the number that can be adjusted by the driver. Driver B can also cut the robot speed in half so that the robot can move slower for more precise maneuvering.